Hi guys. Okay, everything is working great. About the panels, it is kind of funny that we have a Ruby conference, and instead of having Ruby questions, we'll talk about Elixir and JavaScript. But okay, uh, yeah. As let's start. Okay, my name is Maciej Mensfeld. As mentioned, I'm a software engineer, and for the past 10 years, I've been commercially working mostly with Ruby and Ruby-based software, not only Rails, but also plain Ruby. I'm the creator of KARAFKA framework, and the past year I've spent building a platform called Koditsu for comprehensive insights and employees, programmers evaluation. If you have any questions, you can drop me an email. I also run a blog about Ruby, mostly about Ruby. And here's my Twitter account. And please notify me if I speak too fast. If you have any questions, just tell them. If you want me to explain something better, don't hesitate. Just tell me. Or if you have any questions, I think it's always better to just have a talk when it's a bit of interaction in between me and you guys. So feel free to ask questions. Otherwise, probably you will forget till the end of the talk. Here's an agenda. We'll talk a bit about Kafka itself. We'll talk about Kafka plus Ruby. I will make a short introduction to what KARAFKA is and how it can help you with Rails-based applications. And I will give you some use cases, quite interesting, I hope. So let's begin. Okay, how many of you heard about Kafka? Awesome. How many of you use Kafka on a daily basis? Oh, yeah. Well, it's a great technology, and just a reminder, Kafka is a streaming platform. It's a distributed streaming platform, and it's a messaging system. It can be a messaging system. With Kafka is tricky because you can give it many names based on how you use it. It is designed to handle a lot of data. It is designed to be extendable without any downtimes. It was designed with broadcasting in mind, which is, in my opinion, one of the greatest features of Kafka. And it allows you to build event-based systems. It can act as a backbone for bigger organizations. It can be used with multiple applications at the same time, with multiple projects. It scales really well. Who uses Kafka? Everyone. All the big players use Kafka because it gives them the advantage of handling a lot of events. As far as I remember, LinkedIn transfers around 600 gigabytes of data per day using Kafka. So in my opinion, it's a lot. The same goes for Shopify. Shopify extensively uses Kafka. The initial design itself is really simple. You have a Kafka cluster, and you can send any type of message, binary, JSON, string messages into it, and you can take it out. You can even stream data directly from the database using connectors, which means you can just tell your PostgreSQL, for example, to send any data change to Kafka. And the same the other way around. The whole Kafka concept is around topics. You can think of topic as a namespace where messages go. Topics are divided into partitions. They can be divided. It depends on your case. You don't need to use partitions. You can use a single partition and it will work as well. quite well. But if you need to scale, if you have a lot of data, you can create partitions. And you can create customers groups. Customer group gives you possibility to speed up multiple processes and make sure that only one of them will receive a given message out of Kafka. It is really useful if you have multiple applications and you want to make sure that each of them gets a message. In a case like that, each application will be a separate consumer group. So this was the short introduction and now Ruby. And with Ruby is, it's not the fastest language ever, but still it works really well with Kafka. There are a few implementations of Kafka client for both writing and reading into it. And which one you use will depend heavily on your use case. The first one, the oldest one, is JRuby Kafka, which is only a wrapper around the native client, the Java client for Kafka. The downside of it, the biggest advantage of it is that it is supported by the Kafka team, which means that probably it won't be outdated, and it will be maintained. It does not work with CRuby, which means that if you have a MRI applications, you won't be able to use it without rewriting your application to JRuby. And well, you need to go into Java world to use it, unfortunately. There used to be a Poseidon, a great library that is no longer maintained, but it still works. People still use it. I don't know why, because it's a really bad idea to use unmaintained software, but well, they use it, or they just did an upgrade. It has many downsides, only a few advantages, so I don't recommend using it. And the newest one that is maintained, and hopefully since it's backed up by Zendesk, it will be maintained for a long time. It's Ruby Kafka. It covers almost whole current API of Kafka, which is 0.10. And it's a default driver for KARAFKA framework. There is a tool written on top of Ruby Kafka, which is called Phobos. It is a micro framework that wraps it around and makes it easier to use, because using a raw driver is like using a raw MySQL driver, for example, to build applications without active record or any other higher abstract layer. And there is a KARAFKA, the tool that I wrote, on top of Ruby Zendesk, Kafka Ruby. KARAFKA is a micro framework, and it was designed to simplify Kafka-based application development. And it allows developers to have the same Rails-like feeling when they work with Kafka. Kafka is totally different than a standard HTTP request. It works differently, but even then, you can use KARAFKA to get the same feeling, the same development performance, and you don't have to worry about low-level details of working with Kafka, which is, I think, really good, because developers should focus on the business logic, not on implementing and working with lower-level stuff. It is fun, obviously, but most of the time, it's not what our customers pay for. And it was designed, as I said, to build Kafka-based applications faster, to process faster data than we could do with standard HTTP APIs, and to handle events and messages without having to worry about their source. As I said, I thought that there is too many things that developers have to understand in order to start working with Kafka directly, using Ruby Kafka or any other driver, there is this whole bunch of settings, of things that you need to understand before you get into things you need to do, which for me is a big overhead, because when you have a software and you add a new team member, you'd expect him to just do his job, not spend 2 weeks on understanding how this piece of software was written and how it works. And you might ask, why even bother with Kafka? So many of you heard about it, and almost none of you use it. So maybe it's not worth it. Maybe standard HTTP APIs are enough for 99% of cases, or even more. Maybe it's just the next technology that will, that pop up, and it will be gone in a few years. And the answer is no. For me, the biggest disadvantage on the architecture level of HTTP is that it does not provide broadcasting, and the producer of a message and a consumer, they need to be aware of themselves, which means that they need to know the context. If I ping a HTTP endpoint, I need to know the place that I'm sending a message. If I need to notify a new application, I will have to change the producer. So the producer is aware of a next application that it needs to notify. So for me, it sucks, because it adds a complexity to systems. With a single broker, you don't have to worry about it. You just send messages, and like I speak to you, hopefully you're listening to me, but I don't need to be concerned about it. I just speak, you either listen, you decide to listen or not, but it's up to you. And the same goes with Kafka. And if you think about it, all we do, it's all about messaging. Our life is asynchronic. I speak to you, but I don't expect to get a reply that you've heard what I'm saying, but hopefully you do, after each sentence. And reality works like this as well. We send an email and we don't wait doing nothing until we get a reply. So the question is, why our applications don't work that way? Why do we constantly do things synchronically? Why do we send requests and wait for answer instead of doing other things, and if the answer comes, we will just process it? And this is why Kafka was designed, but it was also designed and built on top of things that you guys probably know, which is Ruby Kafka, which is celluloid, which is Sidekick most of the time, and it brings, for bigger applications, the Rails filling. And if you need to do a really small job, it can follow a Sinatra pattern with a single file and a single configuration file, and everything will work. KARAFKA imitates a bit Rails with its routing engine, with its application controller, application worker. It has a CLI. It has a responder, which was based on Platforma Tech decent responders. It works a bit differently, but it follows the same idea. Okay, it's hopefully it's visible enough. And it follows a similar approach. If you get a message, it will be routed. It will be scheduled to Sidekick if you are not running an inline mode, which will execute automatically every message without a Sidekick backend. But if you have a Sidekick backend, which is a default, it will run in Sidekick. But it all happens without you having to worry about it. You just have a controller, you have things, you put a code you want to perform, and it will be performed. It is a single gem, so you can use it really easily. You have to just create a gem file and install it, and just execute installer. It will create a simple frame for you. And as I said, because of how Kafka works, you have way more options that are simple routing that directs a request to a given controller. You have many more options because you can send binary data, you can send text, you can send the JSON. KARAFKA by default works with JSON, but you can obviously configure it to work with any other type of messages. You can even configure groups dynamically. So for example, you can have multiple applications, different applications, and you can make sure that a single message is sent to just one of them. KARAFKA makes things easy because it makes things under the hood. You don't have to worry about initializing workers. You don't have to worry about sidekick stuff. Well, you have to on the same level as with Rails. Most of you probably create just configuration file for sidekick, and that's all. So it will look exactly the same here, with one difference. You can do way more with it. And the controller. This is probably the biggest difference between Rails controllers and KARAFKA controllers. KARAFKA has a single action always, which is called perform. And this is the code that will be performed when a message from Kafka is being received. And this is what will be executed either inline, if you have an inline mode, or in a sidekick process at some point. And the params is basically a JSON that was received from Kafka. So if you decide to switch, for example, from HTTP APIs to Kafka-based APIs, you don't have to do anything on this layer. If you send the same data, it will be handled in the same way. So you can just copy-paste your code, make sure it works, test it, obviously, but then it will work exactly the same. Params are, I think they are directly taken from Rails itself. We have the before enquete that acts as before action if you have some noise in your messages, because for example, you get a lot of information on a given topic. You don't want to process all of them, or for example, you don't want to process all messages. You can just reject them before they are enquete to sidekick, which gives you a huge performance boost and a filtering layer. There is a CLI with some helpful methods to get details on how your application looks, how the flow looks, because KARAFKA is, it was designed to imitate partially a bash flow. You can just pipe applications. You can generate a message, pipe it through 5 other applications, and in the end get a result, which is really awesome. And on top of it, when you get a HTTP request, you do some stuff and you generate a response. Single request, single response, simple as that. Again, this is a next difference in Kafka and in KARAFKA, because when you get a message, when you get an event, you can have 0, 1, or multiple messages that are being generated as a response to a given message. And responders help you organize and control that. They give you a layer to describe how the piping should work. When you get a message, should you have a one-to-one relation, or should you send multiple messages when a single event is being delivered to your application? It is really good when you have multiple KARAFKA applications, because then you can easily design a complex systems that will react upon events without having to worry. about the source of the event. And the performance part, it depends. It heavily depends on what you do. KARAFKA itself is it's not a complex software, so the biggest impact on performance is on your side. Obviously, it won't. If you use sidekick mode, it won't be faster than raw sidekick itself. You can use inline mode, which is faster. It has some downsides, but you can always read the documentation and figure things out. And also the message is a factor. It's not a factor only for Ruby, it's a factor for every Kafka-based system. If you send bigger messages, it will work slower. You need to parse a bigger JSON, you need to handle the memory stuff, things like that. It's not the KARAFKA downside. But the performance, in my opinion, looks really good. With a single process, you can handle 30K Kafka messages per second with a single, as I said, with a single process, which I think is really good. If you send messages to Kafka from Ruby, you can get from 1 millisecond down to 1/10 of a millisecond to send it. You can also switch asynchronic mode, which will send the messages later on. You don't know when, but it should be sent. For example, for less important data, and if you don't want to have overhead at all on your processing, you can just use asynchronic producer. It will take care of it somewhere in the background in a separate thread. It scales as well, and it scales pretty well with few scaling strategies. The strategies come directly from Kafka, how Kafka works. But you can, first of all, it scales with threads, with Ruby threads. It scales with Kafka partitions, and it scales with clusterization of multiple processes. And I won't go into scaling details. It's all in the documentation. But you can process things really fast. Thanks to how Sidekick works, you can handle reentrancy. You can handle retrying if something goes wrong. So it is really good for asynchronic processing. And it works with Rails. Most of startups that at least I've met start from a single monolithic application. And at some point, they get really heavy. They get big, it's really hard to maintain them, and then the main guy behind a given startup decides, let's do microservices. They're so awesome, we'll eliminate all the problems, all the microservices will have separate databases, APIs. On paper, it looks awesome, but then if you decide to decompose this monolithic application, it might become a nightmare, because on one side, you want to decompose. On the second side, you need to provide new features, right? You have customers, they report bugs, you need to fix bugs. They report features, you need to provide new features, and so on. And it all becomes nightmare. I've been there, done that. I don't want to get back to that, never again. And Kafka and KARAFKA is great for a case like that, because you can do it slowly. First of all, you can just start sending messages. Send any data you think that is important to Kafka, and later on think about doing anything with it. If you have a new feature, if you have a new use case, just spin up a single empty new Kafka application and make it work. It will be isolated. Your old system does not need to know anything about it. You can create a simple app, listen on given topics, do what you need to do, and send the data back to Kafka. And do it again and again. And at some point, you will notice that now you can extract modules of your base monolithic app. You can extract whole functionalities and hide them behind Kafka as a backbone. KARAFKA includes a simple application, simple gem as well called water drop. It is used to send messages to Kafka. It wraps around Ruby Kafka and fixes some issues that Ruby Kafka has, and I don't know why the guys are not willing to fix them ASAP. So we decided to wrap it around. Sending messages is really easy. You just send them. The only thing you need to do is convert them either to JSON or send the binary stuff or send XML, whatever you want. And do your normal stuff. And I have two examples. One of, I don't have on a presentation, but I will start not from this one, but from an easier one, a Shopify. Shopify helps develop KARAFKA. They joined the team with some performance fixes, with some bug fixes, I believe half a year ago. And they're using it to monitor part of their infrastructure. What they do is they just send data to Kafka, they gather it in their subsystems, and they process this data. And Kafka is really great for monitoring because you can do both. Check the data if it's as expected, and react if the data is not being received, which means that some of your systems are down and are not working. So you can really easily create heartbeat monitoring for any system. And the second, a bigger case, is my startup that I'm working on for like last 10 months. I think it's called Koditsu. And as I said at the beginning, it's a comprehensive platform, blah, 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 code review, blah, blah, programmer evaluation. And what it really does, it takes Git data and it performs a data mining. It takes all the open source cool linters and tools to check it out. It assigns errors to people. It checks who makes those mistakes, when, why. It tries to understand how your software works and how you can make it better. And it's, just to give you a short description, it's built from 10 Ruby on Rails and KARAFKA applications. It handles 500 up to, I would say, 1K commits daily, with 300 people's work that is being monitored currently, and with 2 million offenses detected and 60K new insight and analysis checkpoints that are being added to the databases daily. And Kafka is great for that. When it acts as a backbone, a message bus for communication, you can have small, really small applications with really small databases. Some of them are, I don't know, 4 or 5 tables in database. You can switch them transparently. You can make them go downtime. You can disable them for 1 hour, 2 hours. Then you can just bring them back, and they will reprocess what they didn't. So this is great advantage when you have dynamic environment where things change. If something goes wrong, you just shut the application down. You fix stuff, you bring it back, you don't lose any data. Everything is in Kafka and it waits for you. Obviously, if you have a real-time stuff, you need to make sure that it's up and running. But sometimes, if you can, just shut it down, fix stuff, test it, and bring it back. Bring it back. And since each of the applications in KARAFKA has a name, you can just change the name. Kafka will think that it's a new application, so it will give you all the data, and you can check it out. Then, using your original name, you'll get all the data you didn't have, but you have tested it, and it works really well in a case like that. Obviously, one case that is not presented here is when you have a single big application. You also can use Kafka with KARAFKA as a message backbone, and it has the same advantages. If you slowly transition from a internal API, I mean, writing something directly to Active Record, taking it out, doing the same stuff. But if you do it using Kafka and KARAFKA, at some point, you'll just remove a huge namespace, put it into separate application, and that way you can make big systems less complex. If you want to contribute, obviously we're on GitHub. If you can, please star it, because if you don't have stars, people don't use it. And if people don't use it, you don't have stars, which is pretty obvious. But there are some issues. KARAFKA has a great documentation. The quality of code is really good. That good that Shopify wants to hire me all the time, which is really good. No, but really, it's a great case study. You can read more about Kafka, about KARAFKA. I post some blog posts about it, but it's really simple. We have an example application that you can just execute. And the only thing that is tricky is running Kafka itself. Don't try to do it manually by downloading sources, setting up the Java environment and things like that. It sucks. It takes a lot of time. Kafka uses internally Zookeeper, which sucks, which takes a lot of time to set up. Just go to a Docker hub, pull a Docker image, spin it up, and it should be enough for you to play with. If you need commercial usage, you can use either Kafka as a service or hire a DevOps or play with it and set it up. Okay, I think that's all. Thank you.
Okay, thank you. So, are there any questions to Maciej?
So how would you choose your message broker in the middle? Obviously you went with Kafka, but there are many other choices, like RabbitMQ or ZeroMQ or whatever. So in which cases Kafka is good, and in which cases you would go with something else?
Yeah, that's a good question. And it really depends, to be honest. When I decided to go with Kafka, none of the other solutions had broadcasting, which means that I would say have the same problems as with HTTP-based APIs. All the applications would have to be context aware. I don't know what is the current state of art on RabbitMQ, but I believe that ZeroMQ still does not have broadcasting. Correct me if I'm wrong. I used to work with RabbitMQ 4 years ago, and it had some DevOps problems. It had some problems with scaling, so I wouldn't recommend it now if it's the same. And the last thing is that when we were doing the research on which broker to choose, I've asked my DevOps, the DevOps guy that I used to work with which one would you be willing to work for the same money? And he picked Kafka. So, which is a really, really important factor, I think, as well. It does not create problems. You can monitor it. There are open source tools to monitor. It scales really well. You can scale it both ways without downtimes. KARAFKA supports switching nodes. So, for example, you could, if you would have your infrastructure on AWS and, let's say, Azure, you could transition without downtimes from one to another. So for me, it's really great because I like to have a choice. Thank you. Any more questions?
You said about using Sidekick as for background jobs in KARAFKA. So you have Kafka as a first layer of asynchronous processing, and then you have Sidekick.
Yes.
Why do you want to have those two layers? Can't you just use Kafka for asyncs, or
Yes,
or just? So why do you need
KARAFKA,
it?
you can with KARAFKA. KARAFKA has an inline mode, which allows you to process things directly. When you get them from Kafka, they will be just processed. But I'm lazy. I didn't want to implement stuff that guys from Sidekick did, and they did an amazing job with retrying, with UI, stuff like that. So I decided to add it as a next layer because of that, because I'm lazy.
Okay, thanks.
With Sidekick, you don't have to worry. for example, with scaling, right? With KARAFKA or any other Kafka-based, you would have to have partitions. If a single Ruby process is not enough for you in terms of how fast Ruby processes things, you will have to spin up next partitions and then rebalance with processes. With Sidekick, it just gets enqueued, obviously to Redis, and then you can rebalance it in a standard for all of you way.
So I had a question about Sidekick, but since it was answered,
Okay.
I just want to know how many hours, man hours, do you spend basically keeping it in operation, Kafka and Redis, when they crash?
Well, this is an interesting question because when they crash, I just restart them because I have the data in Kafka. I process stuff, it does not stay in Redis for too long. If it goes down, I can just start from the Kafka offset that I had. And for critical stuff, sometimes I switch to the inline mode. And with Kafka, you don't get the guarantee that the message will be processed once. You can end up with a case when the message is being processed, for example, 2 times. It will be at least once, but it can happen that when, for example, a process crashes in the middle because you've killed it, the offset won't be committed. It also depends on the security level you want to reach with Kafka, because you can commit offset per each message, or for example, when you batch messages, you can commit it after 100 messages, which means that if you kill the process before you commit the offset, you have to reprocess 100 messages. But for filtering cases like that, you can use the before enqueue filtering, and you should be good with it. I am.
Okay, any other questions?
Who is it now?
Okay, so let's say I'm adding your gem to my application that's currently using Sidekick as the main background processor, right? Will I still have access to like lower level Sidekick settings?
Yeah.
Like, you know, retry and low, like how
You-
it works actually? Because you define like all this logic inside your control layer, right?
It happens automatically,
Okay.
but you can override everything. So if you have your, let's say, customized workers that you'd like to use to process KARAFKA jobs, let's say with the lowest priority, with some other things, you can just set up your own base worker in terms of your business logic and make it consume what KARAFKA is giving you.
Okay, and is anybody using it with Sidekick Pro or like enterprise one? You know,
I don't
support
know.
for batches and stuff like that.
I don't know.
Okay, cool.
I
Okay,
no one pinged me like that.
I hope Shopify does then.
They don't.
Okay.
At least they didn't tell me that they do it, and
Cheap bastards.
so I don't think so.
Okay,
But,
thank you for answer and thank you for a great presentation.
You're welcome.
Anyone else? Okay, so thanks again.
Thank you.